So we're in section 5.2 now. So direct variation means that we can write this equation written y equals k times x, where k is not 0. So we're just multiplying x by something to get y. K is called the constant of variation. So for example, we could say something like y equals 3x. That is direct variation. You multiply x by 3 to get y. And 3 would be our constant of variation. We can think of this, or it actually is, it's a line with slope k. We can think of this as y equals mx plus b, where the y-intercept, b, equal to 0. So we can think of this as y equals 3x plus 0. The slope is 3, and the y-intercept is 0. That's what direct variation is. A line that goes through the point 0, 0. If we divide from y equals kx, if we divide both sides by x, so if we divide both sides by x here, I'm going to divide by x, these cancel out, and I get that k equals y over x. The constant of variation, the slope, the rate of change, the rise over the run, is constant. So however we want to say slope, rise over run, rate of change, the slope is constant. Y over x is always a constant. Here if we divide by x, we'd get y over x is 3. The slope is 3. The rate of change is 3. The rise over the run is 3. So direct variation always looks like this. Y equals kx, where k is some constant number, just some number. And this is a line with slope k and a y-intercept of 0. So with direct variation, don't overthink this. Don't make it more complicated than it is, because it's not really complicated. So let's look at some examples. I just want to show you some different ways that you might see direct variation. So the problem might ask you, is this direct variation? So number 1, 4y equals 5x. What we want to do here is solve for y. Get y by itself. So to solve for y, to get y by itself, what am I going to do here? Divide by 4. So I'm going to divide both sides by 4. Those cancel out. And I get y equals 5/4 x. Does this look like y equals kx, some number times x? Yes. So this is, yes, direct variation. So to decide if it's direct variation, see if it looks like y equals some number times x when you get y by itself. Let's look at another one. (2x plus 3y equals 6). So we want to get y by itself. So we're going to solve for y. So what's our first step to start getting y by itself? I want to get this 2x out of here. How do I get rid of that 2x? Do I divide by 2x? I can think of this as plus 2x plus 3y equals 6. Subtract 2x. So those go away. 2x minus 2x is 0. I get 3y equals 6 minus 2x. And now to get this y by itself, I'm going to divide everything by 3. Divide everything by 3. Well, these go away. And I get y equals 6 divided by 3 is 2 minus, and here I'm just going to write this as 2/3 x. 2 minus 2/3 x. Does this look like y equals some number times x? No, we have this 2 here messing everything up. So this is not direct variation. Because this 2 makes it so it doesn't look like this. But this is still a line, right? Y equals 2 minus negative 2/3 x. Still a line. It's just not a line that looks like this. Okay, questions on that example? Yes? To be a direct variation, it has to look like this. Y equals some number times x. And nothing else. It has to look like this. All right, so for this problem, it tells us y varies directly with x. Now when you see this written, y varies directly with x, what that means is y equals k times x. Y varies directly with x means y equals some number times x. The problem says y equals 40 when x equals 8. We want to write a direct variation equation. Well, the key here is find k. We need to find k. And to do that, I'm going to plug in x and y into y equals kx. That's what a direct variation is. Well, y is 40 equals k, which we don't know yet, times 8. They tell us y equals 40 and x equals 8. Well, how do we get k by itself? How do we solve for k? Yeah?
You divide both sides by 8.
Divide both sides by 8. These go away, and I get k equals 40 divided by 8 is 5. K equals 5. So my direct variation equation is y equals 5x. We found k. K is 5, so my variation equation is y equals 5x. And if I plug x equals 8 in here, 5 times 8 is 40, just like they said. Yes?
Oh, never mind, sorry.
Uh-huh.
How did you get from 5 equals k to y equals 5x?
So our direct variation always looks like y equals kx.
Yeah.
So we used this x and this y to figure out what k was. So then I just plugged, I said, well, y equals kx. My k in this case is just 5.
Okay. Yeah.
And now the problem might say, what is y when x equals 12? Well, that problem is just asking us to plug in. Plug in x equals 12. So we get y equals 5 times x, 12. 5 times 12 is 60. When x equals 12, y equals 60. All right, questions there. So the key here is a direct variation always looks like y equals some number times x. All right, let's say that 15 US dollars is worth 150 pesos. We want to write a direct variation. So our direct variation always looks like y equals kx. So let's call the pesos x and the dollars y. Or do I want to do it the other way? I'm going to do it the other way. What's that? No. No, it just depends on how you set it up. So I'm going to say that 150 equals k times 15. I'm just plugging this x and this y into my direct variation equation. Well, how do we solve for k here? Yeah? Divide by 15. And I get k equals 150 divided by 15 is 10. So my direct variation equation is y equals 10x. To get pesos, we multiply dollars by 10. The next part of the problem says graph the direct variation. Well, first I'm going to make a table. X, Y. And I'm going to pick nice numbers for X. How about 1, 2, 3, 4? Y equals 10 times x. Well, 10 times 1 is 10. 10 times 2 is 20. 10 times 3 is 30. And 10 times 4 is 40. And now we're going to make a nice graph. I'm going to do my y-axis by tens. 10, 20, 30, 40. 1, 2, 3, 4. And there is my direct variation graph. Whoops, I wanted this one. There we go. And that would be a graph of the direct variation. All right. Since k, questions before we go on? Really, direct variations, we're just working with lines. It's just a line, and the k is the slope. Since k is the slope, if k is positive, greater than 0, our line, our graph, is going to go uphill. If k is less than 0, if k is negative, our graph is going to go downhill. When our slope is positive, our graph goes uphill from left to right. And when the slope is negative, our graph goes downhill from left to right. So just whether or not k is positive or negative gives you some information about the problem. Okay, we're good so far. Okay, last thing for today. Using a table. So the problem says, is this direct variation? And we have a table. X and Y. Two, 5. Whoops. 2, 5. 6, 15. And 10, 25. So in order for it to be a direct variation, we need the slope has to be constant, and we need the y-intercept to be 0, because we need it to look like y equals kx. Well, let's check. That's 2, that's 2, that's 10, that's 10. The slope?
It's 4. Yes.
Oh, it is 4, thank you. The slope is 10 over 4. For each of these, that is constant. So we have the slope constant. Let's check our y-intercept. If we go down by 2 here, well, let's reduce this fraction. We can divide everything by 2 and get 5 halves. So if we go down by 2 here to get 0, how much would we have to go down here? We'd have to go down 5. 0. The y-intercept is 0. I'm going to say y-int equals 0. So this is direct variation. And I could write the equation y equals the slope, 5/2, times x. And we can check to make sure we did it right. Plug in x equals 2. 5/2 times 2. Well, 2 divided by 2 is just 1, and I get 5. So we've done this correctly. How about this one? Going up by 1s here. This goes up by 2. This goes up by 4. That goes up by 8. Yes.
I have a question.
Sure.
So an answer to that one.
Okay.
If if on the test I were to write 15 over 6x, would that still count? Or do I have to simplify it?
15 for this?
For that one, yeah. Like, does it have to be simplified?
No. No. I'm not going to be that picky about that.
Okay.
Usually we try to simplify it, but as long as your fraction is right, that's the important thing. All right, and your answer is the slope constant.
No, because it's exponential.
Right, that's 2 over 1, that's 4 over 1, that's 8 over 1. Not constant. So this is not direct variation. Yes?
So I'm confused. On the first one, you went from 2, then 4, 4, and then 5, 10, 10. I thought it had to be the same amount of times every time for it to be constant.
The slope has to be constant.
Yeah,
So-
but isn't
10 divided by 4 is the same as 5, because we can reduce 10 over 4 to 5 over 2. So 10 over 4 is the same as 5 over 2. Does that make sense? Okay. And that could happen on problems that you get on your homework. These might not be the same number each time, going up on the x's or going up on the y's. Well, what you have to check is the fraction. Is the fraction you get the same each time? So you might have to reduce the fraction to check that. That's a very good question. And that's kind of along the lines of what you were asking, Zach, is could you write this as 10 over 4? Could you write it as 5 over 2? Could you write it as 20 over 8? Any of those would be okay as long as it's the correct fraction. Usually we try to reduce. But. All right, questions? Okay, our homework. This is section 5.2. All right, there we go.